All right, welcome everybody to the Digital Learning Network here at NASA's Johnson Space Center. We have Endeavor Elementary School from Cocoa, Florida. They're actually going to be connecting to Mission Control, the International Space Station Flight Control Room. Now I'd like to introduce folks inside Mission Control. We have Public Affairs Officer Pat Ryan and Miss Laura Beachy, who is an Ethos Officer inside Mission Control. So now let's go ahead and take away. Go ahead and Mission Control and talk to the students.
Thank you, Michael. I'm Pat Ryan with the Public Affairs Office here at the Johnson Space Center in Houston, and with me is Laura Beachy. She is one of the Ethos officers who is a member of the flight control team that is watching over the International Space Station as it flies. Laura, explain quickly for us what an Ethos officer does. What parts of the station are you working with?
So I'm working with the environmental and thermal aspects. We keep the space station at a certain pressure and temperature for crew comfort. All of the equipment that's powered generates heat, so we have a water cooling system that takes the heat away from all of that equipment. We manage ISS emergencies. If a fire were to occur on board, or let's say we were to get hit by a piece of space debris and start losing pressure, then we help the crew safe themselves and potentially try to isolate the leaking module. We take care of if a toxic spill occurs. We help lead the crew to safety and guide the team on the right steps to take to keep the crew and the vehicle safe. We provide for the experiments that come out of Marshall. We provide them with smoke detection, access to space for any experiments that want to use the vacuum system. It's a really cool job, and we get to do a lot of coordinating with our IPs.
A lot of different places. So there's a good idea of what Laura does here, and I think we're ready to take your questions.
When the astronauts breathe on the space station, where does the carbon dioxide? A little louder.
Yeah, I think your question was what happens to the carbon dioxide when the astronauts breathe on the station. But yeah, a little louder the next will help us. Well, what does happen to the carbon dioxide?
So we have two systems that collect the carbon dioxide. There's one on the Russian segment and one on the U.S. On the Russian segment, we have the Vozduk, and on the U.S. segment, we call it the Seadra. So both of those systems can collect all the CO2 out of the air that pass through them, and then we hold on to them in these beds, and then eventually it gets dumped overboard. Or on the U.S. side, we can actually take some of that CO2 back and recombine it with hydrogen and make water.
Great. Okay, next question.
Do you work alone?
Do you work alone?
No, I work with a lot of people. So you can see in the videos of the control center, there's a lot of people in the room that we all work together with. And then even at my console, I have a whole team of people that we take turns working at the console, and we take turns, doing our paperwork and all our coordination. So there in the view, you can see, gosh, at least 10 or 15 people that are in the room right now. We're all working together for the same goal.
And each of those people that you see that are in this room right now are working on a different part of the space station, watching different systems. And each one of them has another team of people in another room in the building somewhere that are helping them keep up with what's going on.
Okay. How is the cabin atmosphere created?
Louder.
How is the cabin atmosphere created?
How is the cabin atmosphere created?
Yes, so we fly nitrogen and oxygen up to space station to keep the station pressurized. And then we also have two pieces of equipment that can generate oxygen. We've got the Electron on the Russian segment and the OGA on the US segment. So we can constantly make oxygen, and then we've also got this stored nitrogen that we can add in when we need to.
We can bring oxygen up, but that costs it's heavy, and it costs a lot of money to fly things in space, and that's why we have systems that can make it out of the things that are already there.
That's right.
How do they take showers in space?
So that's a really good question.
They don't.
Yeah, really they don't. Most of the crew members just sort of have to wipe themselves down with a cloth. So it's just soap and water, and you kind of just have to wipe yourself off.
Can they sweat in space?
Yes, the crew members can definitely sweat in space. The sweat acts a little bit differently. It kind of will stick to their skin because of all the surface tension, and then can all the water can collect, and then they have to wipe themselves off with a towel to get it. And then we actually take that sweat and collect it, and then we can reprocess it into clean drinking water.
Why is all the air taken out to the food package at one space?
Why is the air taken out of the food packages?
So I'm not the right person to fully answer that question.
Well, the biggest reason is that that's how they can store it for a long period of time. As I was saying before about oxygen, anything that you bring up to the station, it's difficult to get things up in space, and that includes the food. But food is very important. You have to have it. So you send a lot of food that is made to be able to last on board for a long period of time. It can be up there for years before it's eaten. And you take the air out of those packages so that it doesn't spoil while you're waiting for it to be eaten. There's actually different kinds of food. There's some of it that comes up in other kinds of packaging, and they have a real variety of food. But the thermostabilized and freeze-dried things, you're right, they come up in packages with no air in them.
Why is it important for humans to explore space?
Why is it important for humans to explore space?
That's a great question. So for me personally, I just have this goal and drive to learn everything and all we can. And I think space exploration just gives us an opportunity to satisfy that goal, to learn as much as we can. We're learning a lot about the history of the solar system and the history of our planet by exploring space. Just ISS in particular gives us an opportunity to work with our international partners for a common goal, and all work together for something. And on ISS, we're learning a lot about the way that humans adapt in extreme environments for the body and the mind, and we're doing a lot of research on medicine and how things like fire reacts in space, and all of that is helping us to understand just our bodies and the systems more, even on Earth.
Why is there a satellite on your mission patch?
Are you which mission patch are you thinking of?
The one in space.
Is that the Expedition 39 patch? Because I know that there's a star above the International Space Station on that patch. Patches has all the crew members' names, and it has an image of the station and the Soyuz vehicle that takes them there, and that star that's above it on that patch is meant to represent explorations of the future. As Laura was saying before, we want to explore space to go find out what's out there, and there are going to be future explorations that go beyond this space station, they're going to go back to the moon and go to asteroids and go to Mars and go to other places. And all of that is represented by that star on the Expedition 39 mission patch.
How can oxygen start a fire in space?
So oxygen itself won't start the fire. It also needs, so we need the oxygen, we need some kind of ignition source like a spark or a match, and then we need something to fuel the fire that would actually burn, like some clothing or what would act as your wood in your fireplace on the ground. So you need all of those three pieces, and we take a lot of precautions on board to make sure that those three legs of the fire triangle won't
all
combine, and start a fire. And then our firefighting tactics involve trying to eliminate one of those three legs. We can take out the oxygen source, or we try to eliminate the spark, or take away whatever it is that's burning.
Oxygen could be a part of a fire in space, just like it could be a part of a fire on Earth, but it doesn't burn just all by itself. There has to be something else there.
That's right, and we take a lot of precautions with the materials that we fly on board to make sure that they're not fire propagating, and managing our oxygen levels so that they don't get too high and become a fire hazard.
Why do astronauts train in space?
You want to ask the question again?
I mean, train in water.
Why do astronauts train in water?
Yeah, so the crew trains at the NBL down here in Houston, and the training underwater gives them an opportunity to experience as close to weightlessness as possible. So we've got this huge above-ground pool for them to get in, that they have enough space to put on their suits. We've got a mock-up of ISS under the water, and so that's as close as we can get here on Earth, where we have gravity, to the feeling like there's no gravity.
It's a way to make it feel like you're weightless for an extended period of time. We have another way to make people feel weightless for really short periods of time when they fly on an airplane that does a parabola, and at the top of that arc, people inside it experience weightlessness, but only for about 20 seconds at a time or so. Underwater, they can feel pretty much like they're weightless for hours at a time.
Why does air pressure change when door locks are closed?
So when a door lock is opened, I think maybe what you're referring to is that there could be two different pressures on either side of a door. So if a lock is open, then you allow a pathway for air to pass through, and then for the two pressures on either side to equalize. So then you feel that feeling of maybe if you're on the side of the door with the higher pressure, you lose a little bit of pressure because it'll go down to the lower side. Or if you're on the side with the lower, maybe you feel that burst, or that moment where the pressure is equalizing and your pressure on your side is getting a little higher.
But naturally, the air pressure is going to seek a lower. It's going to try to even out. I can't think of the right scientific word for it.
Equalize.
It's going to try to get equalized. So if you have high and low pressures at the same place, they're going to try to get back to the same level.
What does internal control system do?
And so I think you might mean, in reference to what I do, the internal thermal control system. So for the internal thermal control system, that's that system where we have all these water loops running through the space station, and we collect the heat from all the batteries and all the equipment that generates heat on the space station. So we collect it in our water loop, and then it comes to, we call it an interface heat exchanger. But so our warmed up water lines will then flow past really cold ammonia lines, and we transfer our heat to the external thermal control system, where it'll then get radiated out into space.
How do you stay warm or cool in space?
So it helps to be cool to start with.
It does. And then on the space station, there's actually air conditioners in a lot of the modules, just like you have at home. Well, of course, they're set up a little bit differently.
Right.
But so the space station itself, there's a lot of heat from the equipment that's running, from the crew members, just body heat. And then we run our air conditioners and collect all of that heat to keep things cool for the astronauts. And they can call down and tell us, hey, I'm too cold. Can you make it warmer in here? And we can send some commands and adjust things for them, or they can, tell us they're too hot and cool it down for us.
What do you enjoy most about your job?
So for me, I love the opportunities to coordinate with the international partners. So we work with the Russians, the Europeans, the Japanese every day. I really like that. I also definitely work with some of the smartest people in the world, and we get opportunities to be really creative and innovative. If something breaks, then we can all get together and think about the coolest ideas to fix it, and really we get a lot of opportunities to think outside the box and use equipment for things that it wasn't necessarily designed or created to do. I really love that. It's a really fun job. It's really dynamic, so it keeps you on your toes. It's constantly changing.
Who or what inspired you to pursue your job?
So when I was in high school, I had a really, really great physics teacher. And he used he did a lot of demonstrations in his class to show us how fun physics could really be. So I opted to pursue physics in college. And while there, I developed a strong interest in biophysics and also astrophysics. So after graduating, there was really no place else to go. So here at NASA, I can explore my astrophysics interests. And then for me, ethos was kind of the perfect place to learn a little bit about biophysics in the body and environmental control.
What is the average temperature in space?
So space can get really, really cold and really, really hot. I've heard it can get to negative 450 Fahrenheit and up to 450 or 350 Fahrenheit. So it really depends on where you are relative to the sun and whether or not the sun is shining on you at that moment.
We've even heard astronauts who are outside the station during spacewalks talk about how they can feel a dramatic change just as the station moves from in the sun to in the shade, from sun in sun to sundown, or sunrise again in the morning, and they have to have heaters in their gloves and in their suits turned on to compensate for it, because it can change. Temperature outside around them can change by about 600 degrees in a matter of just a few minutes.
Yeah, I've heard that too. Even with their eyes closed and their visors down, you can really feel the change.
How much does sunlight affect the temperature in space?
Yeah, so that's a great follow-up question, because the sunlight is really what drastically makes an impact and is really the only way to warm up the space around the crew and around ISS.
How much of wastewater are you able to reuse or recycle?
How much wastewater are we able to reuse?
Yes. So I've heard a stat that we are able to recycle more than 90% of our wastewater now, and that's with all of our systems operating properly. So we have a system called the regenerative ECLS system, and so we can collect urine and reprocess it into really clean water, that sweat that we talked about earlier, the carbon dioxide to make more water and make more oxygen.
Condensation in the air. They wring out their towels.
Yep.
Everything.
Yeah, and that's really important because we end up saving a lot of money, so we don't have to fly up water, and we save a lot of space. The space is very limited on the space station, so that way we don't have to store it, and we can put other more important pieces of equipment there instead.
And just as important, for future missions, when we're going to go far away from Earth and can't keep sending up supplies, we have to come up with a system in which we can reuse all of the things that are there. If a ship that's on its way to Mars or someplace can't wait for another shipment of supplies from Earth. So that's why we're developing these systems on the space station, in order to be able to have a way to keep astronauts safe and well supplied when they go out away from Earth.
How much water do they use on the ISS each day?
So we use a lot of water. As an ethos, we try to take into account that on average, a crew member may drink about 2.5 liters of water a day. So that's more than one of your soda bottles on the ground. So with 6 people, 2.5 liters of water a day. Let's see, that's what? 12,
That's,
15 liters of water per day. And then that's split between the U.S. crew members and the Russian crew members. So we work together to make sure that all of our crew members have enough water always.
But and then, as you said, 90% or so of that 15 liters gets reused, gets recycled. So we don't have to supply a new 15 liters every day.
Right. That's right. Oh, and we just got a new experiment on board, the veggie payload, where the crew's growing food. So now we're having to start accounting for a little bit more water each day so we can water the plants.
We have one more question, if it's okay.
Sure.
If we have access to all these technologies in space to transfer waste into water and things like that, why don't we use them more on Earth?
Well, we do use them on Earth. Some of the special systems that have been developed on the International Space Station are in use on Earth right now. It's a different philosophical and in some cases a political question in different areas of the world about why they don't use them more than they do right now. But in fact, the water purification system that Laura was talking about is in use in places on the Earth right now, and especially because it's a fairly compact system, has been able to be distributed in areas of the world where they don't have and can't afford their own systems, so that the station science and the station technology is being used to help people on Earth right now.
Yep, that's right. And some of our systems kind of do what our Earth's atmosphere does in terms of evaporation, and then it rains and condensation, and we package that into a small box and to make it do what our huge Earth can do.
All right, and this is Michael Hare at the Digital Learning Network again. I want to thank you guys for joining us today. And Endeavor Elementary School, would you like to say bye to the folks in Mission Control?
Bye. Bye. Thanks for your questions. They were great.